Hello, class! Those of you who have chosen Muggle Studies are interested in Muggles, how they live, learn, survive. This class will teach you how to not only understand, but interact with these strange creatures on a regular basis. To do this, we must first understand their math concepts, starting with the triangle special segments, arguably the most important lesson in the chapter, as the Muggle community uses these terms frequently to describe the world's geometric shapes and problems Muggles use. Muggles use special segments to find the centers of triangles. The first segment is called a perpendicular bisector. A perpendicular bisector cuts one side of a triangle into two equal parts and is perpendicular to that side. Where all the perpendicular bisectors meet is called a circumcenter. The circumcenter is equidistant from all the vertices of the triangle. Sometimes it is even outside the triangle if it is isosceles. The second special segment is called an angle bisector. It cuts an angle in half. Where these three segments meet is called the incenter. The incenter is equidistant from all the sides of the triangle. Like NQ is an angle bisector. It splits angle N perfectly in half. MQ and PQ are congruent because an angle bisector is equidistant from all sides of a triangle. Therefore, 12 is equal to MQ and PQ. This concludes our first lesson on Muggle triangle geometry.
Is to assume the opposite of the given statement. This means you are going to state the opposite of what you are trying to prove. The second step is to continue along this line of logic and create a paragraph proof until you reach a contradiction in the given statement or in a known postulate or theorem. The final step is to conclude the proof with a sentence. Therefore, since this leads to a contradiction in blank, the proof blank must be true. Let's try a problem together. Here you are given triangle XYZ. Your given information is that XZ is greater than YZ. Prove that angle X is not equivalent to angle Y. Step 1. Assume that the measure of angle X is the same as angle Y. Step 2. XZ is equal to YZ by the converse of the ISO triangle theorem. Step 3. Prove your contradiction. This contradicts the given information that XZ is greater than YZ. Therefore, the assumption that angle X is not equivalent to angle Y must be true.
Our next lesson explains triangle inequalities. This is a somewhat easy lesson, important but easy, so it is sort of a freebie. Oh, look at that, I rhymed. Let me first help you make sense of the first theorem that appears. If one side of a triangle is longer than another side, then the angle opposite to the longer side has a greater measure than the angle opposite to the shorter side. Boy, that's quite a mouthful. What this means is that the longest side of a triangle will be opposite the largest angle, and the shortest side will be opposite the smallest angle. These Muggles certainly do find a way of making things seem much more complicated than they are, don't they? The next easy concept which Muggles insist on complicating is this. How do you get from point A to point B in the shortest distance possible? You draw a line straight from point A to B. What this theorem says is that in a triangle ABC, the distance from point AB cannot be equal or less than the sum of AC and CB. Or the sum of two sides cannot be less than or equal to the third side. These two final theorems are called the SAS inequality or hinge theorem and the side-side-side inequality. The hinge theorem states that if two sides of a triangle are congruent, then the measure of the included angle will determine which triangle has the largest third side. The converse of the hinge theorem, or SSS inequality, says that if two sides of a triangle are congruent to two sides of another triangle, then the length of the third sides of the triangle will determine which has the greater measure. Whichever side is bigger, that triangle has the greatest angle measure. The problem that we will do for this compares triangle ABC to triangle DGE. Compare angle BAC and the measure of angle DGE. To compare these two angles, we must look at the measures opposite them. In triangle ABC, angle BAC is opposite a side with a measure of 4. In triangle EDG, angle DGE is opposite a side with a measure of 5. This means that angle DGE is greater because it is opposite the longest side.